Hello, this is Alan from the Mokanaman at YouTube with another modelling video. Another update on the 3D printing series. I'm holding the camera in selfie mode and looking pretty good actually. The last few videos I've started printing in PLA, and 3 videos ago I talked that I was having a lot of problems, and I demonstrated in a couple of videos about unclogging your nozzle, calibrating the 3D printer, as well as cleaning out the extrusion block on the Up Mini 3D printer, which is a fairly cheap 3D printer, but every 3D printer is a bit different and handles different materials differently. I've done a lot of reading on forums, blogs, other people that own this 3D printer, other 3D printers, and printing in PLA in general. I've done a lot of experiments, and besides a couple of small pieces, the backpack for the Grimball, a lot of the prints I've done has failed epically. I've actually got about 10-15 pieces that just failed miserably. I'll show a photo or whatnot. What I will show, just quickly, this is an item that I've 3D printed, assembled, and in the process of painting. It's not too bad, and it perfectly fits on the back of the Grimball, according to the software that I've drafted with, and yeah, it's pretty neat. That was done in PLA before I had problems, and parts of this gun, the nozzle and the actual ammunition chamber, is also 3D printed, and it sort of looks alright as well. Now, the problem is the extrusion block, which is just below the nozzle, is very close to the intake, or where the stepper motor is. So the stepper motor is right next to the heat exchange, or a metal component from the heat exchange, and the heat, as it generally travels up, is going into the chamber where the plastic is. Now, this 3D printer has a roof and a door. It's enclosed in a box. And the problem is, and especially on warmer days, all the heat is trapped inside it. Now, this can be advantageous to ABS printing. Now, the problem with PLA printing, it prints at a lower temperature. It feeds into the heat exchange, gets melted down, and it extrudes out of the nozzle and is printed in blobs or liner blobs to build something up. Now, when the heat inside the heat exchange and the assembly builds up, and we've actually had a look inside the assembly, we know we've got the stepper motor, a bearing next to it, and the plastic feeds down in between the two. When there's too much heat building up in there, it's nowhere to escape, and it softens the material. And when the plastic is fed in into the heat exchange, where we see it gets blocked, it curls up, and then the remainder of the plastic in the heat exchange extrudes out. It gets stuck, and it tries to push the filament down to get heated, but it can't. It blocks, and it makes the clunk 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 sound. Then I have to pull it apart and drill it out. What I found with other people that own this exact same 3D printer is they have the doors open, and we can see here and we can hear it, we've got a fan, and they open both doors and they cool the inside of the cabinet, because it doesn't matter if the plastic that goes down on the membrane board is coming out hard or not. It's not going to warp or lift up. Then I had my second problem, so I started cooling the inside of the box, and I was laying down some plastic, and the plastic was not etching to the board properly or sticking to the board. It was lifting, it was curling, and it was just fucking up and turning into spaghetti. So I could print, it won't block, but it won't make it into a shape that I was happy with. It wouldn't stick together. Another bit of advice I found, that if you layer a different material besides this board with the holes, like a glass or a bit of plastic, and you covered it in double-sided tape, that it'll just stick directly to the tape. And I've done so. I bought sellotape, double-sided tape. And we're going to have a look quite close in. You can see the strips of tape, and it's actually sticking to the tape and not the little holes and gripping onto that. And as we can see, I am printing a absolute massive piece. This is actually a base for the Grimmel. Now the problem is, when you're printing in ABS with this particular 3D printer, large flat pieces have a tendency of curling. Thought PLA would be perfect for that, but it just won't handle PLA. So a little research, a little thinking, a little changing, even though what I'm doing right now, the manufacturer highly recommends not to do, because it's quite unsafe and it's dangerous for the machine. That the doors are open. I'm not going to be silly enough to stick my hand in there. No one in my family is silly enough to stick my hand in there. And we're running cool air in there, cooling the top, the main extruder head, the actual material, and because the heater has a thermo gauge, it knows how hot the heat exchange is. The heat exchange has to be at a certain temperature, and if it's been cooled down slightly, it'll just amp it up a bit. So it's going to maintain over 200 degrees, it's going to melt the plastic down, it's going to print it out. A happy ending. At the end of the video, we'll see how this piece turned out, and we'll compare it to some of the failures. And here's the second major experiment I wanted to pull off with 3D printing. The first one was making parts to add to model kits. The other one, of course, is making dioramas. Now, I overcome my problem with PLA printing, and funnily enough, I was able to do it quite flatly. Now, this is a small print bread to a 3D printer, and this was made in many components. The disc by itself, and multiple buildings which were just flat, and I did all the battle damage. The one here was a failed print. I'm going to utilize it anyway. And here is a board. You can see there is a slight curve because it still does warp ever so slightly, though when I was trying it with ABS, the warp was almost like an arc. It was very apparent, and then it started getting a bit shoddy because the calibration was completely off, as the surface was not dead flat. Though nonetheless, this is coming out quite nice. Unfortunately, with all the experimenting, all the tuning, and all the mucking around I had to do, I produced a lot of waste, a little bit of rafters, a little bit of support, and just some prints that just went absolutely haywire and wrong. This was one of the actual round bases that just completely failed. I'm going to keep them anyway because it's going to become further debris and fodder for the base. There's all sorts of interesting shapes and textures, so I would be quick to throw them out. All in all, thank you very much for watching, and until next time, you'll see this completely finished in a couple of weeks' time. Catch you guys later.